Good evening, good afternoon, wherever you are. Welcome to this webinar, first episode of series of episode of Kscien Spotlight. In this webinar, we have a very special guest today. He's with us, Dr. Wolfe. He's a professor from Harvard Medical School and he's a director of Visual Attention Lab in Birmingham Women Hospital. Actually, he has a very long CV and he has a very he has too much achievements. I cannot read all of it. I've already shared his CV with you. So most important achievement we see in his Google Scholar profile, there are a huge number of citations. So we are very glad to have him right now online from USA. Thank you, Dr. Germany, and you have the mic. Please go ahead.
Share them. Okay.
Yes, you see it.
Okay, very good. Okay, so the gorillas don't mean anything. I just like that picture. Well, I can talk about gorillas later if you want. I'm going to talk about a research strategy known as use-inspired basic research, and I'll give one example from my own research. And this, I think my instructions were to give a relatively short talk, and then I will be happy to take questions of any sort if you would like. So you often get a story about research that looks like this, more or less, that that somebody is doing basic, fundamental, pure research somewhere, and that eventually that leads to some sort of applied research. A sort of a standard model of this would be somebody in a biolab somewhere develops a molecule that might be useful as a medicine, and that leads to an applied study, a clinical trial, to test whether that medicine is useful. So the original research might be pure biology, and then you might do a trial in mice, and then you might go off and do a trial in humans. Some years back, I guess it's over 25 years ago now, a researcher named David Stokes at the Brookings Institution in the US published this book on what he called Pasteur's quadrant that argued for a different way of thinking about the space of research. And his idea was not to think of research as a sort of a one-dimensional arrow, but to think of it as a two-dimensional space. On the x-axis of that space was how relevant is what you're doing to immediate applications in the world. And on the y-axis was how relevant is this work to the body of general knowledge about how the universe is put together. And he divided this space up into quadrants. Ooh, now it says there are 26 people in the waiting room.
Dr. John, I'm sorry, there's some problem. Just I'll take the host. I'll admit them and I'll come back to you. I'm sorry for that.
Don't. Oh, did you make me the host?
Yes, you are a host. You can admit them.
I'll just. I assume it's okay to admit them all.
I'm afraid
I just admitted everybody.
Okay, thank you.
If that's. Oh, yeah. The trick is to make me a co-host, not the host. So if you make me co-host, you can still do all that stuff. But I will keep a little eye on this too. Anyway, okay, we've got this lovely two-dimensional space. Stokes divided it up into quadrants. The first quadrant here of stuff that's not terribly relevant immediately, and maybe it isn't going to transform our understanding of the world. There are lots of words you could put in there, but you might call it curiosity driven. I'm a visual perception researcher. There's a lot of work in that quadrant for us. You see this cool visual illusion, and you say, "Gee, I wonder why it looks like that." And that's a perfectly uh, interesting thing to do, and it would live in this sort of curiosity-driven um, quadrant. Now, Stokes was more interested in the other three, and he identified each of them with one sort of canonical scientist. So in the pure research department, he talked about the work of the physicist Niels Bohr working out the structure of the atom. And in the purely applied um, uh, quadrant, his model was Thomas Edison, the great American inventor of things like the light bulb and the phonograph. Edison's concern was much less about whether or not he was understanding the basic science of the light bulb. He just wanted a light bulb that would work. Um, the quadrant that gave the title of his book is what he called Pasteur's quadrant. Um, he was thinking of Louis Pasteur in France in the 19th century doing work that was increasing our understanding of um, of fundamental biology, and at the same time was leading to pasteurization, how you made your milk safer for human consumption. And this is what he called use-inspired basic research. And the idea here was that you would there's well here let's there's the whole space, and you can think of this as a sort of a research loop. So for use inspired basic research, the way to think about it is you have a problem out there in the world of some variety. What you're going to do as a basic scientist is look at that problem in the world and say, what's the fundamental question there that we want to answer? We might eventually want to solve this problem, but what's the basic science behind this problem? We're going to pull that basic science into the lab and and study it, and then transition that back into the world in some fashion if we can. And with a bit of luck, maybe we'll have some real impact in the world after going through this loop. So it's not that we originally go out and try to solve the problem in the world. What we try to do is figure out what's the underlying science that would be important if we were going to solve the problem. So let me give you one example from my own work. I study visual perception and visual attention. In particular, I study visual search, how you find what you're looking for, and why sometimes you miss things that you're looking for. I imagine that many of you have seen these Where's Waldo pictures, though you may know them by a different name. It's Where's Waldo in the US. In the UK, it's Where's Walter. Oh no, maybe Walt. No, no, it's Where's Wally in the UK. It's Where's Walter in Germany, I think, and he gets a different name all over the place. If you've got a new name for him, stick it in the chat so that I can learn a few more. And if you're looking for him here, you will be very disappointed because he's not in this little piece. But if I was to say to you, can you find a bear? You would find one. You'd find two, actually. Um, and the processes by which you do that are the sorts of things that I spend a fair amount of my time studying. Now, these sort of Where's Waldo things are fun. In the real world, there are a lot of search tasks. Well, we do search tasks all day long. I mean, looking for your shoes in the morning is a search task of some sort. But we also pay people to do a variety of socially important search tasks. Can you see my mouse? Is my mouse moving around
Yes,
in some
yes,
kind of?
yes, we see it.
Yes. Oh, good. So here are a couple of pictures of mammograms, people searching for breast cancer in X-rays of the breast. The dots on top of it are actually eye tracking. One interesting way to try to understand how people search is to actually measure the movements of their eyes. But that's one important search task. Um, Airport security here provides another important search task where you're looking for threats in luggage. The satellite surveillance people spend a lot of time looking at overhead imagery, asking, I don't remember where that is, but that's some interesting piece of the world in satellite imagery land. These are all important search tasks. And oh, as it says on the slide, a lot of these important search tasks have the characteristic that what you're looking for is very rare. So, I mean, on a broad scale, breast cancer happens a lot, but if you are somebody who is screening for breast cancer as a radiologist, in North America, out of 1,000 women, there'll be only probably 3 cases or so of actionable, something that looks like actionable cancer. If you're at the airport, obviously, most of the bags that are going through the checkpoint do not contain guns, bombs, or knives. So you're looking for something that's, why is it going the other direction? You're looking for something that's very rare. Um, and we wanted to ask the question, um, does it matter that the target is very rare? So we'll do this as an example in baggage screening, just for well, because we were working with the US airport security people at the time. But you can try this. Um, well, it won't be easy for you to. Well, the 3 or 4 people who actually um, are visible to me on screen can give a response. But the task here is to decide if there's a threat in this bag. If you see a threat, you can give it a thumbs up, and if you don't, you can give it a thumbs down or something. The wrench isn't considered to be a threat, so you're probably okay there. You can, whoop, come on, let's go. You can try another one.
Mm,
No, nothing there.
might be.
Yeah, don't think so. So they're rare, right? Threats are rare, but here's a threat. That's a knife.
Mm,
That's actually an easy threat, actually. What's really difficult in airport security land is explosives. Um, the what Just as an aside, what you're looking at in these sort of images is color-coded X-ray. Um, a Organic material comes out as orange. Metal comes out as blue. If you're looking for an explosive, what you're looking for is something orange that could be an explosive interacting in some way that you don't like with metal that could be a detonator of some sort. Very difficult if you think about the way you pack a bag, right? When you're packing a bag, you are not thinking about, oh, I'd better keep all those plugs and wires from my computer or whatever separate from for example, if you, well, nobody has magazines anymore, but glossy magazines like the journal Science or Nature, for example, um, in X-ray that looks beautifully like a sheet of explosive. Anyway, very hard task. Target is very rare. Does that matter? That's the question that we were going to answer. So We're going to show people a lot of bags and see how well they do at the task. Um, we were asking this question and we couldn't just look up the answer because nobody had done the right experiment. Why didn't anybody do the experiment? Well, what you're doing in the research lab land typically is you're doing a task like this where you say, can you find the letter T? It can be rotated and you say, yeah, okay, I can find it. Um, you would find it much faster if I said, can you find the letter T? It's green. And you would, here over on the right, you can see that the reaction time, the time it takes you to find the item is much faster if you know it's green than if you don't know it's green. If you're doing an experiment like this, you would have a T present either on every trial and ask them a question like click on it or tell me which way it's pointing, or typically on 50% of trials. You would never do an experiment where your target was only available a few percent of the time. It's just not a question that would be interesting to ask until you have this use-inspired question. We had a very specific question. What happens if the items are rare? So we went and looked. So let's imagine that we took 20 bags that have guns and knives in them. I should say what we did was we wrote software that basically packed bags so that we could control what was in each bag. So we'll take 20 bags and we will we can put them in a stack of images that's got 40 images in it. So that would be 20 bags out of 40, one bag every on half the one target on half the time. That would be 50% prevalence. Oh, we only used guns and knives in our experiment because if you're not using trained folks, explosives are just too hard. There's a reason people go and learn how to do these tasks. So in one condition, we'll have bags, targets on 50% of the bags. And in our other condition, we'll show them 1,000 bags with targets on only 20 of them. So that's 2% of the time, 2% prevalence. So that's still higher than it would be in practice, where, of course, real weapons are very, very rare in bags, but at least it's much lower prevalence. And what we're going to be interested in, yeah, nobody's going to do this experiment unless they've got a good reason. A very boring experiment for the observer. The observer is sitting there going, no, 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 no. And it takes a very long time to even get data on 20 guns and knives. But we did have this use-inspired reason. And I will show you here some data from volunteer, non-expert subjects in the lab. And I'm putting up a big note that said that these are volunteers because if they were the folks at the airport who we have worked with, I wouldn't be able to tell you the real error rate because the real error rate is regarded as a security sensitive information. So what we've got here, I'm going to measure the error rate, how often they miss the target in this case. And when the target is present half the time, with the particular stimuli that we have, they missed 20% of them. When the targets were present only 2% of the time, look what happens. The error rate jumps up to about double. They miss about twice as many. Now, in any task like this, there are two types of errors. There are misses where you don't find what you're looking for, and false alarms where you label something, in this case, as a threat that's not really a threat. And what you find is at low prevalence, false alarms go way down. But if you ask yourself, if you're the guard at the airport, which kind of mistake do you want to avoid? If you make a false alarm error, well, that means the guy's bag has to be opened and examined. If you miss a real gun, bomb, or knife getting onto the plane, of course, that can be a disaster. So these are errors that you don't want to make. And the evidence suggests that when things are rare, you make many more, much higher percentage of miss errors. Well, that's kind of interesting. But as I say, those are just people in the lab. Would this ever happen in the real world? So we took this experiment to actually to our hospital and to those radiologists reading breast cancer images. And we, in this case, is a former postdoc of mine named Carla Evans. She and I took 100 cases that had half of them had cancer on them, half of them didn't. And what we did was we put those into the regular workflow at the hospital very slowly because we wanted them not to notice our stimuli. Now, if they found one of our fake stimuli and said, "Oh my goodness, I just found cancer," a message would come up saying, "Thank you very much. You just, we told them they were participating in this experiment. Good for you. You found the cancer. Don't worry. You don't have to call the patient. We know about this." So that's the low prevalence arm of this experiment. And then we got 6 of our radiologists to read all 100 cases in one block. So they're reading at 50% prevalence. So again, just like the study we did in the lab, low prevalence, very low rate of cancers, high prevalence, 50% rate of cancers. And here's what the data look like. Data. This should look kind of similar. This is very much the same pattern that we got in the lab. But now those red bars come from radiologists who are doing their real job in the clinic. This is they're not just coming and doing us a favor, getting paid a few dollars to be in an experiment. This is what they do for a living. And you can see from the high prevalence case to low prevalence, the error rate more than doubles. They missed more than twice as many of the cancers at low prevalence than at high prevalence. This is the version at the airport. Remember, I told you I can't tell you what error rate they're making. You cannot figure out from my y-axis here how many mistakes actually got made because we deliberately transformed the data in a kind of opaque way. But what you can see is this difference again between high prevalence and low prevalence. And I can tell you that the basic pattern is the same. You at low prevalence, you just miss more stuff. The one-liner version of this is that if you don't find it often, you often don't find it. And this is a finding that other people have picked up on, and it's shown up all over the place. And I picked this as an example of use-inspired basic research because it's got the right parts. So we know that some targets are very rare in tasks that we care about out in the world. The basic question we ask is there a prevalence effect in visual search in general, not specifically at the airport or specifically in the radiology clinic? Is there a basic principle at work here? And so we brought that into the lab to study it. And we've done lots of experiments on this. I can give long, detailed experiments about detailed talks about prevalence effects. After we established it in the lab, then we transitioned it back into the world and tested real radiologists and real airport security officers. And then, whoops, and then I didn't put in a slide because I don't have a good answer there. The last piece of that loop the question everybody should, should ask after I'm done here is, well, gee, okay, you found this. Now what are you going to do about it? I have spent quite a few years at this point writing grants to the US government saying, I've got this great idea about how we're going to fix prevalence effects so that fewer targets get missed out there in the world. And many of those ideas have not worked. They've produced interesting basic science, but that last important piece of this use-inspired basic research loop to then somehow intervening in the world, in this particular case, proves to be quite difficult. All right. Yeah, the gorillas are about a completely different story, but I do like the picture. I will turn things back over to our host and see if you want, do you want to open things up for questions? Do you want people to put questions in the chat? What would you like to do here?
Just earlier, we promised the participant that we have time for questions and answer if you don't mind.
Okay. People from all sorts of interesting places, but most of them are not giving me what country they're in. Oh yeah, all sorts of, all over the place. And people keep entering the waiting room, which is mysterious. Okay, so what are we doing? Are we putting, are we just having people unmute and say something?
Okay, if you don't mind, I'll take the host and I'll manage it. Okay.
Yeah, sure. That's fine.
Just a minute. Well, we are advertising for this webinar. Most of the participants asked about the how you got this large number of citations. The question about the citations.
Well, that's a sort of a, so
in
in the early part of my career, I worked on binocular vision, and in particular, a phenomenon called binocular rivalry, which is a great, interesting piece of basic research. If you put different things in the two eyes, like a pattern of vertical lines in one eye and horizontal lines in the other eye, you can you won't see a plaid, you'll see a fight between them, and that's known as binocular rivalry. And I thought that's great, and I worked on that. I published a bunch of papers, and I think my three best friends read them and sometimes cited them. But then I switched to working on visual attention, and it turns out lots of people are interested in that topic. And if I don't know, obviously, the background of people on this call, but if you ever took a cognitive psychology course or something of that sort, if you heard anything about visual attention, you heard about the work of Anne Treisman, who was my senior colleague, wonderful person. Anyway, she had the leading theory of this, and I wrote a paper that was a challenge to her theory. So I picked the right fight, and people picked up on that and started citing that. And I should say that the use-inspired piece has been good there in citation land too, because yeah, there are people who work on a variety of fundamental work on a variety of real world problems, and the sort of fundamental work that we do is relevant to what they do. So when they write a paper about driving or sometimes about radiology or whatever, they end up citing our stuff. But it's all right.
Okay.
I
Actually,
see a raised hand.
yes, please.
Good.
Who's raising? Dear Professor, I received several questions, really.
Oh, here we go.
Uh,
Oh, there's the question about key milestones that um, um, so the short biography part is that I uh, when I was in high school before college, my it was always assumed that I would go and do something like history in college, and I don't know, maybe be a lawyer or something. But my father, who was a physicist for his whole career, um, got tired of me just lying around the house in the summer reading books. So he sold me to his buddy, um, 2 floors down, who was running a color vision lab. He didn't sell me, of course, for real, but he got me a summer job with his buddy, the color vision researcher, and I thought vision stuff was really interesting, and I learned from him that that meant I should probably major in experimental psychology in college, which I did, and I went off to grad school um, in that. And uh, so I've actually been interested in most of the topics that have been topics in my research life. It turns out I got exposed to when I was a 17-year-old kid in in a lab in New Jersey, purely by chance. Well, not by chance. I had the opportunity because my father had the opportunity to um, do that, and um, I've been lucky to have been comfortably funded by U.S. government grants for many, many years. That certainly um, helps. Um, so, in terms of collaborating with people, I've had uh, my lab for many years. I'm sitting of all things a surgery department at a teaching hospital, so I don't train PhD students. Um, because
yes.
the department doesn't have them. But I have postdocs, and then I have research assistants who tend to go off to graduate school. But my closest collaborators over the years have been my the postdocs who leave the lab but stay connected with the lab, and that's uh, and I've had you know, collaborative relations with a lot of other people in the field, but um, particularly if you're doing what I do, which is basically behavioral research, that hasn't become big science in the way that some other fields have. So I can do what I've done um, without a big team of collaborators. It's a little different than
Dr.
some other fields that way.
Uh,
Uh,
Dr. Jenny, I have received several questions, but some of them they are repetitive questions. So I want to answer take an answer from you for those questions they are repetitively they are asking. One of them,
okay.
they're asking, it appears in your CV, you have been working for several journals as an editor. Does working as an editor helps you in improving your research experience or increasing your number of citations? How it's helped?
I think it is useful um, I think being a reviewer is useful as part of a research career because it gives you a better feeling for what the reviewers are doing when they're reviewing um, your papers. Um, Being an editor is interesting because it to be a reasonably effective editor, you have to be reading, and you have to be sympathetic to a very wide range of um, topics. Even if you're so I was the editor of a journal called Attention, Perception, and Psychophysics, which covers research on attention and all of the senses and stuff. So that's in the broader scheme of the universe, that's not that wide, but it means that I can't just read visual search papers. That if I'm going to be an editor, I have to read papers quite broadly. The piece about citation is interesting because there's been quite a bit in the news recently about abuses of both review and editors, where basically the reviewer or the editor says, you can't publish your paper unless you cite me 5 times in the paper. That's not good behavior. It clearly happens
Sure.
out in the world these days, um, but uh, uh, um, but not by me. One, it does happen as a reviewer from time to time where you get a paper and you say, this is a nice paper. You really, really do need to read this old paper of mine because it's really, really relevant. But it's embarrassing um, if in your review what you do is you basically say that this person, you're in your anonymous unsigned review, you say this person needs to read and cite 15 papers by Wolfe. That's not good behavior if you are Wolfe. But the editorial, doing editorial work is useful. It broadens your view of the field. It's also time consuming and uh,
Yes.
hard work, but it's also um, a particularly if you're somebody like me who's been in a very privileged scientific position, it's part of the work that you should do to support the field. Somebody's
Yes.
got to do that. You're not getting rich by reviewing or editing, but it's important work for people to do. If you uh, people can let journals know that you're willing to review, by the way. Many journal websites simply have a link that says, tell us if you want to review. And speaking as an editor, let me tell you, particularly since COVID, for whatever reason, it's been hard to get reviewers. So, if you're interested in reviewing, and if your department chair or whatever is looking at whether you're reviewing, don't be shy. Tell the relevant journals that you're willing to review. Keep an eye out
So
for,
what
yeah.
I learning from your talk, you prefer to be a reviewer more than being an editor.
Oh,
Other,
editor, if you send the same note um, to the journal and say, I would love to be your editor, yeah, they will say, thank you very much. Why don't you review some papers for us? Um,
that's right.
yeah, so I'm currently, so the journal that I edited for, that I was the editor for once upon a time, um, I am currently chairing the search committee for the next uh, editor. And that's a process. Yeah, it's a job application of a sort. It's not the same as applying for an academic job, but those are uh, more competitive positions uh, that people get to once they've reached a somewhat more senior position, typically, um, and have a track record with the journal and stuff like that. But being absolutely, being an editor, apart from the fact that it meant that I didn't watch any movies, I think, for some years.
Hmm.
When I was in the editor work is often work that you do in the evening after doing your regular work. And so, for the years that I've been an editor, I've often, all right, dinner's
Okay.
over, let's go review a paper.
And another common question facing us right now, they are sending for me from several channels. They're asking, we know that basic research, basic science research, they have too many citations, well, applied research, usually they don't have too many citations. What about youth-inspired basic research? Is it like the basic research, or it is between the basic
Oh, in
research?
terms of
Or
citation, I don't know. I think the difference that you're um, picking up on is that there is an asymmetry in terms of citation between applied work and basic work in the same topic. Because if I do a basic piece of work on, let's say, visual search, somebody who's interested in driving or radiology or overhead imagery or all of those topics might read it and might cite it. If I'm publishing in the more strictly applied literature, I might be doing a beautiful piece of work on the details of a self-driving car or something, but that's going to be relevant specifically to that much smaller
yes,
community. The use-inspired stuff, I don't. Well, so um, the other journal I edited for is called Cognitive Research Principles and Implications. We call it CREEPY for short. Um, but yeah, it gets cited at sort of the same rates as the basic science journals, and it's specifically intended to be a use-inspired basic research journal. So I
yes.
I think the nice
Just
thing about the use-inspired basic research is you can sort of play both sides.
yes, you're right.
Certainly, this has certainly been true in my in asking people for money. In my case,
Yes,
that's typically the government, where when I write a grant,
Let's go.
I think that we should mute iPhone while he's that's muted. You have to mute him or her,
yes,
them.
yes. I'm sorry.
You muted
Yes.
me too.
So
Okay,
I'm sorry. I'm
if
sorry.
I'm writing a grant, I would say here's an interesting problem. Um, you let's say it's about detecting breast cancer, and now I'm going to do I have three goals here. Goal one is some basic research. Goal two is some basic research. And goal three is I'll try this with real radiologists.
Yes,
And in that way, I've been able to move back and forth between basic
yes,
science interests
yes.
and
Yeah,
more applied ones.
I'm sorry we took your time too much. Just last question.
Oh,
Repetitively, they asked me this question also. Which steps or what are the obstacles in your opinion? What's the most common obstacles, or what's the most common problem in doing youth-inspired basic research? The most difficult step.
the most difficult. Well, it's hard to say in general, across all fields of science or anything like that. I'd say if you're working in sort of the broadly speaking medical area, the hardest thing is to be if you're on the clinical side, the hardest thing is to be able to carve out some research time. So I have all sorts of radiology friends who are fascinated by these questions of how they do the task they're doing, but they need to they can't get the day a week free to do that kind of research. Um, Similar sorts of difficulty um, show up if you have a faculty position where you're expected or required to do a great deal of teaching. Again, it's going to be hard to find enough time to get um, to devote to research. I have a career where I have piles of time to do research. The difficulty for my particular position is that I have to get government grant support. If I don't have grant support, nobody's going to pay me. And I quite like being paid um, because otherwise it's harder to eat. Um, so, you know, each and the industry people that often, certainly in the U.S. at the moment, that can look very good. They pay you well. You're spending your time doing research, but very often, if you're working for Google or you're working for Meta or whatever, you can be doing fascinating things, but you're not going to pile up citations because they won't let you tell anybody about it. It's all corporate secret, or a lot of it is corporate secrets. So each of the different ways of having a research life has its own challenges.
Yes.
But if you love research, you know, you pick you find your way in one of them that where it works, you hope. Let me say that if people have specific questions that we didn't get around to talking about, um, by all means, my email is just sitting on my website. You know, by all means, pop me a note and I'll be happy to send you a note back. I will send you depressing notes back about how easy it's going to be for the next few years to come from, let's say, Baghdad to the US to do research. That's going to be its own interesting little problem. But anyway, if I can be useful, by all means, send me an email.
Thank you. Dear Professor, at the end of this webinar, we are very thankful for your very nice presentation, very nice talk. It was really a new idea for us. Thank you so much. Do you have anything to end up with?
No, it's one of the few good things that came out of COVID was the discovery that we can talk to people all over the world without having to fly around. This is an audience I definitely would not have. Well, it would have never been assembled in
Yes.
one place, and the
Yes.
people who are zoomed in from Malaysia and Indonesia,
Yes.
they stayed up really late and should go to bed. It's past their bedtime.
Yes, you're right.
Anyway, thank you for inviting me.
Yes. Thank you so much. We hope in future we can also have you on this program. Very well. Thank you so much.
Thank you. Bye-bye.
Thank you so much. Bye bye. Bye bye. Thank you for all participants. And Garwin will see you in next webinar in February. Thank you so much. Thank you for all of you.